bit of introduction for those who are joining it for the first time. My name is Ravi Sahu, and I'm the founder and CEO of Streos. And Streos is software solutions with AI-powered tools to optimize mine-to-mill value chain. And the way we offer our solutions, we have in one software suite, design, predict, measure, and analyze. All the tools are there. So starting from drill and blast design to prediction of fragmentation to muck pile, and then actually the assessment of the fragmentation can be done in the platform, and then you can optimize several KPIs, from that. So that's just a bit of an introduction about Streos. Without further ado, I would like to introduce our today's speaker, Dr. Alejandro Ferrada Vergara. He is a senior consultant and blasting and explosives at Ferreblast. Dr. Alejandro is a mining engineer at the University of Santiago, Chile. He has master's in business, innovation, and entrepreneurship degree. He is also a professor of the career of mining engineering at the University of Development in the chairs of open pit design in addition to drilling and blasting. He's also international director of the Latin American Lithium Chamber and partner of the Mining Chamber of Chile. Previously, he was a director and vice president of Chilean Association of Explosive Engineers. He's also a blasting and explosives consultant and general manager of the company that he runs, Ferreblast. Professor Alejandro has developed his professional career in explosives engineering in senior positions, supplying explosives and blasting services predominantly in Latin America, and in recent years as a specialist consultant for technical services in a lot of the largest mining companies in the region. Some of them are BHP, Minería Escondida, Minería ASM Centinela, Sierra Gorda, Codelco, Tech, Kinross, to name a few under his belt of experience there. So there's a lot of experience and learning here. So without further ado, I will let Alejandro kick off today's session. Welcome, everybody, and thank you, Alejandro, for the session.
Hello, everyone. Thank you, Ravi, for that introduction. Hello, Fernando, and all the people. I'm really surprised about reading in the chat description. There's a lot of people from everywhere in the world. I'm going to mention some I've read: Belgium, Mauritania, from Chile, people from Chile too, Kenya, Zambia, from US, from different part of the United States, Missouri, Colorado, Houston. So I'm pretty grateful for listening people from everywhere. Egypt, I read there Ibrahim from Egypt. So I hope first of all I want to thank you guys for your interest in this presentation. I will try to do my best in order to make it interesting presentation today about this topic. I'm gonna start by I'm gonna run the agenda to explain. I will give a little brief introduction related to what we do at Ferreblast, so that way you will understand why I'm doing this presentation today, and then we're going directly to a innovation academy. I used to call that way because we just tend to clarify some concepts related to research, development, innovation, technology. I have seen in the past in some works that people used to confuse terms and use as if we're the same things, and we're just clarifying a few aspects of that, based on the experience, using some examples, understanding what we are saying when we talk about mining 4.0, mining 5.0, what does that mean, and where that concept comes from. And then after that, knowing the base of the Innovation Academy, I'm going to explain with a local example a job I did for an iron ore mine, Los Colorados mine in Chile, 2 years ago. I will apply the innovation concepts used in that case study, and then we'll finally giving some other examples of applied innovation in drill and blasting discipline, which is the discipline we love to work with. So let's go. Let's start the presentation. We have 10 minutes to start the session. What about Ferreblast? Who we are? We are a Chilean private company, a consultancy company founded in 2017. Uh, we have a clear mission and a vision oriented to the explosives and technologies in blasting services. But what defines the company is our passion. We are passionate to innovate, becoming the expert in explosives technologies to achieve a blasting efficiency process. So what we do in this company is help our clients to achieve blasting efficiency. What we understand for blasting efficiency is to use the proper explosive at the exact distribution and precise timing to produce the better outcome at the lowest cost. That is what we understand for blasting efficiency, and involves many aspects from the discipline, explosive savings, better fragmentation, vibration control, safety in blasting, etc. So, what we provide services, technologies, and assistance and training in these matters, because we believe that it is possible to achieve a sustainable mining industry, and we try to collaborate optimizing the drill and blasting disciplines aspects. Okay, and we use Strayers for those optimizations. So this is the staff team. We work in this company. We have international consultants. We have representatives in around Latin America, in Brazil, to be exact. We have experienced technical managers in the company. The business office manager, Claudia, runs most of the business administration. And there are some other trainee engineers. Most of them have been my own students in different topics in the Universidad del Desarrollo in Chile. There are several large mining companies, most of them in copper ores, that support us and believes in our work, such as Escondida Mine, BHP Mining Company, Tech. Well, Ravi mentioned some of them previously in the introduction. So those are the companies that have been working with us. So that is the brief introductory presentation. Now let's start with the promise, the Innovation Academy. This is what most passionate I'm about. So I hope you can enjoy this topic from now on. The Innovation Academy. What is innovation important? Why is innovation important? Let's define what is innovation first. Okay, I like to start with these quotes. You may agree that these quotes today, these phrases today, are not pretty much applicable. For some people may sound kind of weird, these quotes. I'm gonna read the fourth one. The first one, this says, everything that can be invented has been invented. who says that director of U.S. Patent Office in Charles Duell in 1899. Everything that can be invented has been invented. Certainly, this guy didn't see the trips to the moon, travel along the space, visiting Mars, it's kind of weird. This another one, it bothers me. It used to be shocking sometimes. Sensible and responsible women do not want to vote, U.S. President, 22nd and 24th U.S. President Robert Cleveland in 1905. There's no likelihood man can ever tap the power of the atom. The Nobel Prize in Physics, Robert Millikan in 1923. I like this one. Who the hell wants to hear actors talk? Harry Warner from the Warner Bros. Pictures, 1920. Those are quotes, are phrases that I call them innovation killers because does not allows the process to make mistakes, to discover new things, to accept things might be different sometimes. Uh, so let's see how does things evolve in time. Innovation is about evolving things. Everything evolves. Now we will see later on that new processes or goods or products replaces the old ones. So that's what we call evolution. And let's see an example taking as example the automotive industry over time. Let's see a transport from the 19th century, the boogie model we call it. We used to say it's 1 HP, 1 horsepower of power. It's a four-shoe drive. So, but let's see what happens next. If we go to the early 20th century, we have the mass production of automobiles. But there was certainly some key aspects from Mr. Ford producing the Model T in 1908. He used to say any customer can have a car painted any color that he wants, so as long as it is black. So there is something that is perhaps not applicable today to the automotive industry. Uh, Perhaps he didn't. There's not studies in marketing here, marketing strategies. It's not a smart strategy. Painting all your cars, all your products in only one single color. But what happened next? Things evolved, and what we have today, we have electric cars that are replacing the old uh, uh, diesel engines. So after that, there will be certainly come a new ways of transport in the future. So that's an example how you can see the evolution of a certain industry over 200 years. Let's see what happens with another example. In similar time frame, we may see the evolution of the energy industry, starting from thermal, uh, the old thermal power plants, going through the hydroelectric energy, and then eolic energy, and today we see several solar panels based plants. The one you see on the bottom right in the screen is a solar power plant. It's a large solar power plant in the northern Chile. In It's called I can't recall the name. It's Cerro Dominador power plant, solar power plant. It's pretty interesting place. It's a huge in the middle of several mine several mines, such as Sierra Gorda mine. Then you have the Spence mine from BHP. There is the old Chuquicamata mine nearby that place. in the northern Chile. So that's another example of evolution in industry. So uh, now we are getting close to how does the evolution involves the innovation. We'll see and why innovation is different from research and development, for example. We will try to understand those concepts, how we can clarify those concepts. Okay, I'm going to be a little academic. Perhaps you may see it's a kind of boring to see too much text in the presentation, but it's necessary for you to understand those concepts. I'm trying to be more clear as possible. But first, we need to know that this person, this guy, Joseph Schumpeter, is an economist and historian from the early 20th century. He defined five types of innovation, and you can capture. There are five news in the bullets. You know, there are the bullets are five news: new goods in production, new production methods, new markets opening, new supplying sources of raw material or consumables, new organization of any industry. So that is why we were mentioning before about the evolution. New things are the evolution of the old things, you know. So well, this person Joseph Schumpeter defined five types of innovation. What's more interesting than that, uh, he wrote about the creative destruction. He spoke about innovations in the manufacturing process that increase productivity, which consists of a process of industrial mutation that incessantly revolutionizes the economic structure from within, uh, and incessantly destroying the old one, incessantly creating a new one. So we are talking about uh, new inventions, new innovations replaces uh, the, the, the old things. Uh, there are two types of innovations that we can perceive in the process. There are some innovations, radical changes, or destroying or replacing the existing models. But there are also some progressive innovation, which is the most common, you know, uh, because they continually fit the process. We'll see a certain example later in the presentation that you will uh, clearly recognize the progressive innovations in a certain process. I will show you an example in the next few slides. Okay, uh, so let's keep talking about the creative destruction. Schumpeter says knowledge or discuss knowledge based in economy. The word innovation comes from the Latin innovare, which is mean into. It separates in into and novus, which is mean to renew or improve something. It refers to the introduction of a new significantly improved type of product, good or service, process, method of organization or commercialization. Business model, you can say that business model, it is highlighted in the presentation because we're going to use it later to define certain requirements the innovation has. Uh, Continuing company practices or rules, workplace organization or distribution or business relations, or simply different ways of doing things that creates value. We'll talk about value later on. Oh, I just forget. Sorry, to mention about the innovation uh, guidelines are uh, defined in a manual. It's not casualty. It's not things that people say, it's a formal discipline, that are described for the, this is an example, the oil, OECD Oslo Manual 2018 collects some guidelines for reporting and using data of innovation. There are examples of that. Same for the research and development discipline, which are all the guidelines are collected in the Fratcati manual. I'm showing in the picture the 2015 version of that. So you can find all these definitions in those manuals. So you can understand what is the difference between innovation and research and development. Where it says I plus D in the title of this slide, I refers to R&D, which is the research and development. Is the English word for innovación, investigación y desarrollo. I just didn't translate all the words. There are certain squares you will see in the presentation that are in Spanish. Perhaps it's an invitation to you to learn some of it, okay? And there are some people from Chile in Spanish speaking too, so welcome, guys. Well, in the research and development, we have to understand that there are basic research and applied research are different, because in the basic research, refers to studies of original works oriented to get new scientific knowledge. Let's say you got a situation with your clients, with your customers, saying, "Hey, help me to solve this problematic." Okay, so what do? As a consultant, you go through the literature, try to research some topics related to the problem your client has, and try to propose a solution. Let's say you find you can't find any solution with the tools existing today. What do? To go for a basic research, trying to propose different hypotheses, theories, or laws. This is the point where scientists makes discoveries, in the basic research. Then the applied research comes. Start from previous works, the basic research, focus on specific targets with specific objectives or goals to achieve, resulting in this stage that certain propositions can be patented for a future commercial benefit. In this stage, the scientists will say invent things based on previous discoveries using basic research. Well, in the third stage, we have the technical development, and that is what the word compounds as research and development. And there is consequence, we do not say development and research, because there is a thing of consequence, First become the research and then the development. That is what we call R&D and not D&R, and you will see, based on that, necessarily innovation becomes after research and development too, because it's a process and consequence, I'm going to talk about later when an example. Well, technical development refers using the new knowledge, obtained during research to produce materials, devices, procedures, services, or organization models. At this point, it is where the know-how and the expertise is obtained. In this stage, the scientist creates prototypes, models, pilot plans to generate products or models. Okay. Then let's put all those things together. In summary, research and development plus innovation, R plus D plus I, are concatenated or are enchained, you know, how that they are connected. It says we used to say research turns money into knowledge because you spend to research and development. So research turns money into knowledge because you invest to increase your know-how, you increase your knowledge. However, innovation, and this is the key word, innovation turns knowledge into value. Innovation turns knowledge into value. It is because it creates value from the knowledge we acquired before. And that is the consequent process, you know. While we say that innovation is a creative process through which economic value is added from knowledge, such as and such a value is obtained from knowledge transformed into new products, processes, or services. And it's not a casualty definition; it's an OECD manual, you know. So there are scientific definition of innovation. The innovation consists of a value proposition based on a business model. That is why I speak earlier about business model and economical value. You know, innovation is necessarily related to obtaining a benefit, a tangible benefit obtained from the economic value. You know, if there is no economic value, no return on the investment, there is no innovation. There are different, I mentioned before, there are different levels of innovation. Radical or disruptive means that is something that it changes suddenly. And progressive or incremental, which means there are small or little advances, are basically a sequence of improvements made to all innovations. Uh, in this second type of progressive innovation, you may find just a few differences between one product and the other, but if you compare the first product to the last one, there are completely different things. And what is the different? Uh, we already talked about the value proposition and the business model and the economic value related to the innovation. And I want to highlight the difference with an invention. An invention is just any creation, no matter the return on investment or profit from benefits, which means it's a simple expression of creativity. You know, an invention, perhaps, let's say, you can be creative by folding paper sheets as an origami, but you're not making money with that. Perhaps you write a book about how to build different figures folding paper sheets. That's the innovation. You know, innovation is always related to creating value. You know, generating economic value from your innovation. Otherwise, it's just an invention or expression of creativity. Many people tend to confuse creativity and invention with innovations. It says, "Oh, I'm just painting the wall in a different color," and it says, "Oh, you're so creative, you're so innovator." No, just creativity. That's it. There's no value behind that. Innovation is related to economic value. Okay, so let's move forward. There is a first poll. Perhaps the moderator can help me with the poll. It's a challenge more than a poll. It's a challenge. Are you able to define if what you see in the picture is an invention or an innovation? We'll give 20 or 30 seconds for you to vote. You can select an invention or innovation. Ravi, perhaps you can help me or support
Yeah,
to
so
with the
yeah, with the
results.
poll is launched, I think we're already getting some responses in.
Thanks for that.
Yeah, we'll leave it another 20 seconds. So some interesting responses here.
Well, at least I don't know. Perhaps in invention and innovation, you may define differently. At least is funny situation seeing that picture. I'm 100% sure it is funny or curious.
Yeah, for the there should be a third option here uh, for audience who have joined from India. They would probably relate to it. We call jugaad. That's another term.
Yeah,
So I think perhaps the next time we'll add that another option based on what I'm seeing.
yeah. Next time we will do that way. Yes, it's a good suggestion. Are we
Okay,
done?
I'll close it. Yeah, so there's a responses are pretty tapered, kind of balanced now. I think invention, we have about like 40%, innovation 60%.
Time for full innovation. Yeah.
Okay,
Okay.
we'll
So
close the poll.
the poll result is Ravi is innovation then.
Yes, 60%
Okay.
innovation, 40% invention. That's the poll responses.
Okay. Great. Uh, well, many people may say it is innovation because there are benefits or of warming the water. Okay, but I would like to touch base on the cost of that. Uh, what about the risk of how do you say um, of being injured because of electricity, uh, lighting your house, creating fire, or perhaps you may losing your how do you call that base? I don't know in English the English word. Uh, you know the cost might be higher than the benefits obtained. There are certain other ways, more safer ways and secure ways to warm your water, you know, to heat your water. So this is to me is no more than an invention, better than an innovation. There is creativity, but there is no value in that except for heating the water a little bit. But the risk is too high uh, against the benefit, because of the electricity, because of the fire risk and things like that. So there is no value. To me, there is no value, no return on investment on this one. So I will say it's an invention. That is my poor result. Just an invention, just creativity, but at any risk. Let's go for another one. There's another example. This is funny. Who invented the light bulb? Who invented the light bulb? Uh, there certainly will be funny answers here.
Yes, we
I
have another poll live now. Give
I, I,
another,
I bet you I bet you, Ravi, that I will see a name.
yeah.
What do you think?
So we have about pretty good responses so far. We'll give another 10 seconds.
Is there any prize for the winner or not?
Yeah, I think we should next time. I think we should put a draw here.
Yeah, the prize will be an invitation for the next webinar. The Spanish version.
Yeah. So we'll close the poll now in about 2 seconds. We definitely, I think the Thomas Edison, I think the well-known kind of inventor here. That's where it's leaning towards all the answers.
Great, good
And
to
yeah,
know. And there is a comment in the chat. It's Hani El Sawani says Edison did not invent the light bulb. He just iterated different designs to find one that worked best. And I thanks for that comment, Hani. I
yeah,
will take your words because after giving you the answer, you will realize what you're saying, and we'll give you an example of a type of innovation, um, certainly with that.
Yes, the poll is closed.
Okay, 100% says Edison.
About 68%.
Okay. Oh,
And
that
then
surprised me. I thought
20% both.
uh,
Yeah, yeah.
I thought most will agree that Edison was the one that invented the light bulb. Okay, okay, guys, this is the truth. The Light Bulb Hall of Fame. You will see that to reach the last version of the light bulb, there were seven, 77 years of incremental innovation. So thank you, Hani, for your comment, because it is what it is. Edison did not invent the light bulb. He just iterated the different designs to find the one that worked best. That's it. That's innovation. That's incremental innovation, progressive innovation. Different small changes in small improvements, one after the other one, and just in this at the end of the day, Edison was just the last one that became famous for the became famous for the invention. But that gives us a a tip. The first innovator is not usually the most recognized one. There are always people that will do things better. You can Another example of that will be, for example, what happened with Facebook. For example, Facebook wasn't the first network for sharing. There were some other before. Um, how do you call that? No, ways to posting pictures. There were some other platforms before than that. So the first innovator is not the one that becomes the all the thing. David is rushing me for how to get soon to drilling blasting. We're going now for drilling blasting, David. Thanks for your message. I'm going running now. Let's go. Let's talk about a little bit about mining 4.0 and 5.0. Okay. Uh, why we say mine 4.0, the industry 4.0? There were in the world has been four different revolutions: the first, the second, the third, and the fourth, and there's a fifth one we will talk later on. The first one was power system. And this is what everybody agrees is a industrial revolution. It happens in the later 18th century and earliest 19th century. And then there was technological revolution at the earliest 20th century. This revolution became with in the hand with massive connectivity, railroads, electricity powering the whole countries. Accompanied with economical growth, line assembly production. There's an interesting movie that examples that the Charlie Chaplin Modern Times is funny to see this. It's an oldies mute movie, but it's funny understanding how that he perceives the 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 innovation from those. Then the third stage, the third revolution was the digital revolution happening later in the 20th century, after the World War One and Two, after there was a complex times for industrial awakening because of the wars. But it started with the Boolean logic and the supercomputers, interconnection, the World Wide Web, the TCP/IP protocols, and all those stuff that built up the internet connection. That's we call the industrial revolution, and it's the fourth revolution, the third revolution, and gives a space for the fourth revolution, which is what we call industry 4.0. And the revolution involves the cyber physical systems, automation and digitization and robotic manufacturing. That is what we call Industry 4.0. And we call mining 4.0 to all those processes, and we'll give you example, David, uh, all those processes that integrates industry for industry fourth industry topics aspects. The concept was first appeared in the Hanover Fair in Germany in 2011. And what we call the fifth revolution, which is still ongoing, pretty unmature, it is the machine learning and AI and data analytics. It is what is happening today. Oh, sorry to disappoint you. This is not about explosives. This is about innovation in drill and blasting. So I will keep going. So we're talking about, then we talk about mining 4.0 when machine learning, AI, and data analytics involves in mining, in this case, in drill and blasting topics. Okay, so let's go process of innovation, efficient use of explosives. I'm going to talk about an innovation in drill and blasting. Perhaps David now becomes happier than before. Okay, what happens with difficulties from poor blasting performance? When you plan bad blasting, you may have negative results, right? Like riffling, excessive dust, vibrations, poor fragmentation, and higher processing costs, fly rocks, poor safety performance, low performance of load and hold, and uh, a lot of aspects like that. But why? What happens when we do bad practices of drill and blasting? It's a classic approach. The more explosive, the better fragmentation. Many drill and blasting or mining engineers apply that approach, and it's not true. It's not true because the conventional blast design techniques are not prepared to keep increasing linear way the use of explosives. That means that using more explosive does not necessarily means improving fragmentation, particularly by exceeding certain limits. For example, vibrations, dust, damage to the surroundings, damage to the mine design, so you got to be careful when you decide to increase explosive energy. Instead, the idea is to be innovation, to do innovation by optimizing the use of explosive. And I'm going to explain how to do that. The problem is in the traditional design patterns, the explosive energy distribution. If we see this from an engineering perspective, it's a matter of a discrete variable, the explosive energy, because it's put in drillings, in boreholes, in small quantities, and uniformly distributed into a continuous element, which is the rock mass. The rock mass, the blasting block is a continuous element. So we're distributing the discrete variable into the continuous element, which is the continuous element is heterogeneous, anisotropic, discontinuous, which is mean anisotropic is different behavior to different directions. It's discontinuous because it's scattered because several structures, geological structures, and it's heterogeneous because it's composed of uh, different textures and different types of rocks. So we're trying to apply uniformity to an to a heterogeneous uh, uh, material. That is what I mean. And there is another consideration. You put the explosive only in the bottom part of the blasting block, in the bottom. The upper zone where the stemming goes, I call it the blind zone because that portion of blasting block can be as 50% of the blasting block. Uh, you don't have explosive there. So you're trying to break that type of rock, all that amount, all the blasting block, by uniformly distributing the same type of explosive all along the bottom half of the blasting block. So this is curious. It's at least curious, you know. Uh, you putting explosive only in the bottom half. What is the idea of innovation in this case? Okay, we have the purpose to reducing the portion with no explosive. I mean the stemming zone, the smallest as possible, in order to give space for the explosive to work over the rock mass. You know, but at the same time, as we, you know, the stemming zone has a function into the design, which is containing the energy. So if I reduce the stemming zone, I have to support and control the energy in another way. So if you reduce the amount of explosive and you give this space to your right, the air deck, you will leaving space for the explosive to work in the surrounding, yeah, but at the same time to cushioning the energy to be used in fragment the rock surrounding instead of pushing the stemming retainer. Okay, Abraham, I will uh, uh, ask you to do your question at the end of the presentation. Um, just 10 or 15 more minutes, we'll stop the presentation and we'll give space for attending questions. There will be 15 minutes of question and answers. Okay. Okay. Improving the explosive efficiency, it means that using less amount of explosive and obtaining better results. I'm going to give you an example. I'm going to jump this slide to show you the example in an application in Chile. This picture is a capture and a screenshot of a video of this blasting made in this iron ore mine in Chile, Los Colorados mine. You will see there the height of the open pit mine. You will see the benches, 1, 2, 3, 4, 5 benches perhaps, and you may see the ejections in the blasting results are no higher than perhaps a third of a bench height. So you may see that there is a very well contained blasting, and the stemming zone is lower than 30% of the whole power column. So there is the cushioning function works for the air deck. I'm gonna show you some trial results. You know, some trial data, some measurements we made. For example, we measured the velocity of detonation. We calculated based on that parameter the detonation pressure, how that moves inside the air deck. You know, we apply some sensors inside, some carbon gauge sensors inside to measure those pressures. You know, and also we measured some other parameters like vibrations, like fragmentation. You know, and we did analysis on the cost and benefit, and we have some conclusions, some outcomes. What are the outcomes? The outcomes is the detonator pressure was reduced between 5 to around 5%. That it is expressed in the surface vibrations or the ground vibrations were lowered by 36%. And then in spite of we were using about 7 to 10% lower explosive, less explosive, the fragmentation was improved by 16% in fragment size, in the P80, I mean. Okay, so that is what we call innovation. It is doing best getting best results with lower cost. So there is value add. There is an economical value created from changes. That is innovation with it. It's an applied example. Okay. I'm going to jump to the later two examples. There is another example of industry mining function measure weight drilling is a technology. It's not a new one, but it's not working in all their performance. We haven't took all the advantages that we may have from that technology. Uh, the measure weight drilling consists of a kit of sensor installed on the drilling rig to read operation parameters and correlate them as the rock index properties. The data that is read from the sensors can be interpreted as rock reliability index, which is uh, related to the rock hardness too. Okay, at that time. So where the rock is harder or strengthened, requires more energy to be drilled. That is what we call energy, a specific energy. It's a function of the pull down, the drain section, rotation speed, etc., and represents the work done per unit of rock, the specific energy. So there are several parameters that that kit of sensors read from the drill rig, and can be correlated to certain rock mass properties like geotechnical units. For example, the interrock properties and the rock mass properties, such as compression strength, elasticity or Young modulus, density, P-wave velocity, geotechnical quality, and etc. So that is what measure weight drilling does. Read parameters on time, and you can be interpreted those parameters as rock property. Okay. In simple words, if the drill rig says, or the MWD says, you are drilling in a softer rock, that means that rock needs less energy to be fractured or blasted. In simple words. Okay. Let's see the last example of process innovation. Now we're going to mining 5.0, which means AI applied to drill and blast. And this is our my friend's Strayos. We used to use for certain services Strayos platform. What Strayos does is ingesting data from all the steps on drill and blast process to for analysis and evaluation, and generate or suggests designs. And you may see that part of the platform uses, for example, measure weight drilling analytics, which is pretty smart, because I see in the future many mining companies are going to drilling automation. Most mining companies such as Anglo American, BHP, and Antofagasta Minerals in Chile, and some others around are implementing automated drill rigs. There are no drivers on that, but not all of them. I remember one service I provide for one certain mining company. They say they were implemented the automated drill, but the manager asked, okay, what is the value of implemented automation? It's just taking off the driver, or there is something else. So what we say, what we can do, if we have the measuring while drilling system installed on the drill rigs, uh, automatically drilling, automatically working, what we can do is to set up a fragmentation model, that can set up automatically the boarding spacing patterns according to the rock hardness, rock strength. I mean, so this model will decide automatically what type of energy, how much energy, what is the better distribution for doing blasting process, and it's a model that you can do automatically. Perhaps in the future, mine engineers will be just sitting on the computer teaching the others how to do innovation and and research and development. probably all professors. Well, that's a bad, bad, bad joke. Why Strayos is part of the mining 4.0 industry? Because it does applies AI, artificial intelligence, to different processes like vibration, airbus management. There is a tool that I like too much. This is rock mass characterization using artificial intelligence. The mock pile prediction and the fragmentation measurements are awesome tools, that can easily to improve um, blasting results evaluation. I mean, so that is a tool that it's simply applying artificial intelligence contributes to economical value obtained from your mining or drill and blasting process. Well, if you want to define or set up a mine to mill improvement cycle, this is the tool for you, because you can, based on new or testing new pattern, for example, doing simulations for achieving different results. You can do it in the paperwork, in the platform, and not making mistakes in the mine site. Everybody knows how much expensive is making mistakes in the mine site. Especially with drill and blasting. What happens when you doesn't achieve your P80 size? The crushing station may have a struggle and stop production. That's a lot of money lost. And to finalizing this presentation, two more capabilities the Strayer software uses are, I mentioned, the fragmentation measurement, the mock pile simulation, prediction, um, the the geotechnical characterization, and it's a tremendous tool. I enjoy working with it because it gives the outcomes I need to evaluate certain processes in the drill and blast. Okay, so that's it. I don't want to extend longer. I'm thinking a little bit late according to the 5 minutes after the agenda. So, Mr. Moderator, Mr. Ravi, you handle this section. Thank you, everybody. Thanks for paying attention. I'm open for your questions.
Absolutely. Thank you, Alejandro, for the amazing session here, and thank you to the audience as well for sticking, this long. I know we are over a few minutes here, so we can perhaps take a couple of questions here. And I know it's top of the hour, so feel free. I think the audience who has to go, feel free to drop here. We'll take 5 minutes to get to the question. If we can't get to all the questions, we will anyways prepare a response and send it over email here. So with that, I would like to start with a question that was asked by. Let me find that. So yeah, here is the question. Are you suggesting that blast designs are generally somewhat poor and not results driven? That is one of the question
Okay.
from Avram. Yeah.
Uh, can you write it down in the chat group, because I'm trying to capture what was
Yeah.
to
I think in
understand the
that
sense of it.
case, when it's context related to the innovation, the design, the blast designs, which were shown in one of the examples, are generally somewhat poor and not results driven. I think there is a context missing to it.
Yeah,
We'll have to go back and look at that. But
that's
there's one other question that was asked is, what was the applications related to managing and tracking the blast movement?
okay. In those cases, I'm gonna answer the last one. because the first one I didn't capture pretty much, but so that is why I asked you to type it down to understand exactly what they want. But when we were doing that blastings sets of blastings in Los Colorados mine, the main concern was by that time didn't know exactly how to apply the technique, so we were trying to investigate in order to obtain certain data inside the boreholes about what is happening inside the air deck. So the main concern was okay. We need what is the limit of the stemming zone to shorten the stemming zone. That was a risk, because when you shorten the stemming zone too much, then you will start having fire rocks and dust, excessive dust, and vibrations also. So that was the main concern and risk. And then we need to know how how much explosive we can lower from the power column, uh, so do not to lose fragmentation. We didn't have negative results, so we started with several testing first. We put uh, different length from different air deck, and we selected the optimal length of the. We're still working on that to define what is the optimal length of the air deck based on the drilling diameter parameter. Uh, but basically, those are parameters we were researching in that time. I don't know if that exactly answered your question. I think.
No, thank you for the answers here. There's another question just came in here. Question is, should the gas bag application at the bottom of the
No.
holes decrease the vibration peak, or should it be used at the top?
Not sure about applying the gas bag in the bottom. There are some research from my from colleagues using stemming retainers in the bottom of borehole, but the purpose is eliminating the sub drilling, for example. Because the energy as soon as goes off the explosive, the shock wave rebounds and spread in the bottom of the borehole, and helps to define a better floor, by saving explosive. But certainly, what decreases the vibration peak is not the gas bag, is the less amount of charge in the power column. Vibrations are dependent on the kilos of explosive. So if you are using less explosive, certainly you will have lower vibration. That's it. It's a mathematical issue. You know. So I'm not sure about lowering vibration using in the bottom compared to the top, but certainly using in the top helps to that, because most of the ground vibration, surface vibration, are based are dependent of the crater theory. The crater Chavera mentioned the crater theory, you know, because it's the last 10 drilling diameters are responsible for all the ejections and vibrations in the surface. So if you modify that formula, certainly you are getting better results in the vibration side, and that's what we demonstrate, I show in the during the presentation.
Great. Yeah. Thank you, Alejandro. We have still questions coming in, but I think we want to be respectful of the time here. I know all of you have to probably go get back to your
Mhm.
day jobs here, but nevertheless, we will answer those questions over email. I want to thank again to Alejandro for taking the time. This has been an amazing session. Thank you very much. And thank you to the audience here for sticking this long and taking an hour out of your schedule and participating here. If you want to learn more about Straos, just reach out to us, how it could be of help. If you want to coordinate with Alejandro as well, his contact details are here if you want to learn more about his experience as well. If you have a feedback about the session, please do share with us. We like to continue to improve how we can present more educational content to you. So please reach out if you have any topics that you would like to share that we should cover in our next series of webinars. Until then, thank you very much. Hope you have a great week, and see you next time. Thank you, everybody.
See you guys. Thank you. And to closing words, for closing, you have my contact details there, and you can email any other questions. We can talk about for hours about it. So thank you very much, Fernando and Ravi and Kimberly, for giving this opportunity. I'm passionate for speaking about general blasting. I hope I'm waiting for you in the next one. Ciao, ciao.
Thank you. Ciao.